Hello there, my name is Jeff Lindstrom. I'm doing a little experiment to find out if possibly the BP oil spill is causing climate changes, also possibly the storms in the Midwest. My theory is darker things absorb heat better than lighter things. This is a scientific fact. So when the sun shines on something darker like crude oil, it's going to absorb the heat faster and increase the temperature. I already hear that the temperatures in the Gulf water are more like the end of August temperatures instead of the end of June temperatures. So this is showing this is a possibility. So what I did is a little experiment. And the little experiment that I'm doing is I'm taking water, putting it in a little container, and I'm heating it with a reptile light to see how much the temperature increases. To give you a short explanation of what happened during this experiment, and I'll show you a little bit of it. The temperature did not increase when we used clear water. It did increase after 45 minutes. It did increase by almost 2 degrees after 45 minutes when we poured oil on top of the water. Now this is the temperature of the water a couple inches down. Now when we added the oil, when we measured the temperature of the oil layer, we saw an increase of almost 8 degrees. It went from 80 degrees to almost 88 degrees. This is a significant difference from what we saw with just water. So the oil layer seems to be holding heat. Of course, it's darker. Possibility some of the light is passing through it and then reflecting back up, but it seems to be collecting the heat. So what this is telling me is that the temperature increase in the Gulf water and then the whole south part of the United States could be attributed to the BP oil spill. Also, the storms in the Midwest could possibly be caused by this due to increased evaporation of water. Because of higher temperature, water is going to evaporate faster, increased humidity, and the Gulf Stream coming north with this hot, humid air and hitting the jet stream and causing these storms that we've been having these last few weeks of June. This is only a theory. I have done some research which says this may be a good possibility. I'm saying scientists do some actual tests on this and tell us, is this really happening? Black absorbs heat, and crude oil is black. So what we're going to do is we're going to do a little experiment. I'm going to take this little tank, I'm going to fill it up with water, we're going to measure the temperature to begin with, I'm going to put a light over it for 30 minutes, we're going to see what the temperature is at the end of the time to see how much heat it gave it. I'm going to pour some oil in that water and I'm going to repeat the experiment and we're going to see what happens. Alright, so we're going to kind of continue on with our experiment. We filled this up with water. There's a little ridge here. I filled it right up to that ridge. That's going to be approximately from the top 2 inches. I've suspended a light about 4 inches above that. It's on a music stand and I have it kind of anchored in place, so it's going to be the same height for both parts of this experiment. First part of this experiment, what we're going to do is we're going to measure the water temperature now with the thermometer that I have that has been calculated against a certified thermometer. It's a laboratory Sergeant Welch thermometer. It doesn't read super accurate. I'll bring it up here so you can kind of see it in the camera light. It's reading in 2 degree mark. So there's 20, there's 40, there's 1, 2, 3, 4, 5, so that's 30. So what I'm going to do is I'm going to stick it in there up to here, up to this point right here, which is the mark that it's supposed to be submerged to. I'm going to submerge it to the same depth in the water in the experiment using a ruler. That way we know it's the same depth. Again, 4 inches, the light is above that. It's a reptile sunlight lamp, so it should heat it up. We're going to give it a try. If it don't work, it don't work. I'm using a timer. I'm going to time 30 minutes on the timer. The timer, again, if you look on it, it's a traceable thermometer. So it's been calibrated. It's a Fisher Scientific product. So it's accurate. When it says there's 15 minutes and no seconds, that's what there is. So I'm going to count it down from 30 and we'll see what kind of change we get in 30, 15, 30, and 45 minutes. I may only go 30. I'm going to see how long it takes for the temperature to rise. So first thing I'm going to do is I'm going to take a temperature to start with. We're going to try and get the same temperature to start next time. This way it's accurate. So I'm going to take on my lamp that I have. If you look right down there, I've put part of a reptile house down there that I can take and use as a reference point to where to take the temperature at. Right at the edge. I'm going to give it some time to get proper temperature. And this seems to be right at 80 degrees. Pretty close. Right between these lines here. And then I'm going to turn the light on and start the timer. It'll beep at 15 minutes, it'll beep at 30 minutes, and it'll beep at 45 minutes if I go that long. I don't know that we're going to need to go that long to get a good temperature raise. 15 minutes. So I'm going to stop that timer. And we're going to kind of check the temperature now. After 15 minutes, we're still right about 80 degrees. We might be 80 and a half. But really not a good enough significance. So, you know, we may have to go an hour even, maybe to get a good temperature raise. Pretty good?
Oh yeah, feels great already.
There's my timer going off.
Yeah.
No, I'm fine. I can do this while I'm talking to you. So you're feeling pretty good, huh? Yeah, I'm still right about 80 degrees. I mean, it hasn't changed the temperature at that depth. And even if I come shallower, it's still right about that amount. So you may have to go more. I got another 15 minutes here, then I'm going to let it run, and then after that I'll take and try it with the oil. Maybe it'll be 89 in 5 seconds with the oil.